First part is solve this equation, giving your answer in x iota y form. Okay, so if we see a quadratic equation, we're going to apply quadratic formula. Minus b is 2 iota, plus minus square root b squared, so 2 iota whole squared, minus 4ac upon 2a. So we're getting 2 into 1. Okay, so 2 iota plus minus square root. What are we getting inside? That's a negative 4 because 2 square is 4 and iota square is negative 1. So negative 4 plus 20. So that's a 16. So 2 iota plus minus 16 upon 2, which gives us iota plus minus 8. So our two roots are 8 plus iota and negative 8 plus iota. And we write z equals this and z equals this. And remember that in this case, the roots are not conjugate pairs because A, B, C are not real. A is 1, B is negative 2 iota, so B is not real, and C is negative 5. Only when A, B, C are real, the roots are conjugate pairs. So that's why these conjugate roots are not conjugate pairs. If they were conjugate pair, the other root would have been x 8 minus iota. So that's not the case here. Okay, second part, find the modulus and argument of each root. All right, so let me write each root separately, then draw it on an Argand diagram, and then find its modulus and argument. Okay, so for this one is 8 comma 1, 8 and 1. This would be real. This would be imaginary. This is just a rough sketch. Okay, so this is going to be the modulus, so square root of 8 square plus 1 square, which gives us under root 65. Oh no, there's a big blunder here. Okay, which is, hopefully you guys got it before me, which is that this is going to be square root of 16. This becomes square root of 16, which gives a 4. So this gives a 2. This becomes a 2 and that's a minus 2. Okay, that's minus 2 plus iota. Okay, now we draw it on an Argand diagram. So we have 2 and iota. So 2 is here and 1 is here. And the other one is negative 2 and iota. So negative 2 here and 1 here. Okay, we need r's for both of these and then we need the arguments for both of these. This is going to be one argument and this is going to be the other argument. Okay. So the modulus for both of them is going to be square root 1 square plus 2 square, that is 5. Same here, square root of 1 square plus, even if you don't write negative 2 whole square and just 2 squared, it's the same thing, so it's going to be square root of 5. Okay, now for the argument here, we're going to use tan inverse 1 over 2. So tan inverse of half in radians, shift tan 0.5, which gives, hold on, my calculator is not in radians. So it gives 0.4636. And for the other one, it's going to be pi minus 0.4636, which gives 2.6779. So the modulus is under root 3 and the argument of one of the roots is 0.464 is a better answer because it needs to be in 3 significant figures. And this is going to be under root 5 and 2.68. Okay. Part 3, sketch on an argon diagram showing the points representing the roots. So we will make one argon diagram, a proper one this time, with X and Y properly labeled, and show both the roots on the same diagram. So, okay, X and Y, and we write real Z here and imaginary Z here. One of the roots was 2 plus iota. So that's going to be placed in the first quadrant. So let's write 2 and 1 here. And the other one was negative 2 and 1, negative 2 and iota. So that's going to be right here. And that's just the answer for part 3.